Yo, what's up everyone? Patrick here, welcome back. And in this video, we're going to do a question dealing with function notation. It's not too bad, just want to get a little bit more practice with dealing with certain function notation. So we're given two functions, f of x equals the square root of x squared minus 2, and g of x equals 2 over x minus 3. And we have to find these two values here. So f of g of 4, and then g of f of 4. So to start off, I'm going to rewrite this one over here. If you see something like this, another way to write this right here is f of g of 4. And personally, I actually like to write it like this. So whenever I see something like this, I automatically convert it to this kind of format. Both of these are the exact same thing. And then it's a lot easier to deal with because now what's g of 4? Well, we would plug in 4 for x in the g of x function. So we'd have 4 minus 3 in the denominator, which would be 1, and we'd have 2 over 1, which is 2. So g of 4 ends up being 2, so we would end up having f of 2, like that. And then f of 2, we plug in 2 for the x value in the f function. So we'd have 2 squared, which is 4, minus 2, which is 2. So this would end up being the square root of 2. Right? So that is the answer for that first expression. Now g open dot f of 4, the way we could rewrite this is g of f of 4, like that. And then what is f of 4? So we would plug in now 4 for the x value in the f function. So we'd have 4 squared, which is 16, minus 2, which is 14. So we would end up having the square root of 14 over here. And then what's g of the square root of 14? We would plug in the square root of 14 here. So this would end up being 2 over the square root of 14 minus 3, like that. So that there would actually end up being the final answer if we leave it as an exact value. You could also rationalize the denominator, multiply the numerator and denominator by the conjugate, root 14 plus 3, and work from there, but I'm just going to leave it like this. Another way you could have done this is you could have created functions. So we could have created a function f of g of x. So we would plug in this whole function into here. So we would end up having the square root of 2 over x minus 3 squared minus 2. And then you can maybe simplify under that radical. And if we did g of f of x, we would take that function and plug it in for that x value. So we would end up having 2 over the square root of x squared minus 2 minus 3. And then from there, what we could do is here we could plug in 4 for that x value. Once we simplify, we would end up with the square root of 2. And then over here for this one, we could plug in 4 for this x value. And we would end up with this over here. I feel like that way is a little bit more complex to come up with the functions first and then do it, especially when you're dealing with more complex functions like this. I feel like if they're asking for actual values, it's just easier to do it in steps with these separate functions. But whichever way works, both ways should give you the same answer.